Welcome to our 15th video. In this video, we are going to discuss matrices and transformation, part 1. A transformation changes the position, size, or shape of an object. Examples of transformations are diffraction, rotation, enlargement, translation, shear, and stretch. We will start with the matrix of reflection. The first matrix is matrix -1, 0, 0, 1, and this is a matrix of reflection in the line x is equals to 0 or the y-axis. Number 2, we have the matrix 1, 0, 0, -1. This is a matrix of reflection in the line y is equals to 0 or the x-axis. Number 3, we have the matrix 0, 1, 1, 0. This is a matrix of reflection in the line y is equals to x. Then number 4, we have 0, -1, -1, 0. And this is a matrix of reflection in the line y is equals to -x. We can go to worked out examples. Example 1. Consider a triangle ABC with the vertices A, 2, 1, B, 4, 1, C, 2, 4. Show the object and the image and the transformation denoted by the matrix 1, -1, 0, 0, 1, then 2, 1, 0, 0, -1, 3, we have 0, 1, 1, 0, 4, we have 0, -1, -1, 0. Solution. Number 1, we are going to pre-multiply the matrix -1, 0, 0, 1. Our object is 2, 1, 4, 1, 2, 4. When we pre-multiply, we are going to get the image as -2, 1, -4, 1, -2, 4, as you can see on that diagram.
The matrix T is equals to -1, 0, 0, 1 is a matrix of reflection on the line x is equals to 0. The line x is equals to 0 is also the y-axis. I have applied that matrix on this jellyfish and I can move it for you to see the property of reflection. So when I move the jellyfish further, the image there also moves further, and the distance between the jellyfish and the mirror line is also the same as the distance from the mirror line to the image. And the image is the faded one, and the angle between the line A prime, and the mirror line is 90 degrees. As we know the properties of reflection, the line that is joined from the object to the image is a perpendicular bisector, and I can apply this same matrix on a triangle for you to get the concept. So I'm going to draw a triangle ABC. So we have triangle ABC. Basically, actually it is triangle FEG, and then we can apply this matrix on this triangle. So I will say apply matrix, and then the matrix is T. My object is T1, that is triangle 1. So I can apply it on T1, and then we can see the image of that triangle. It is F prime, E prime, G prime. I can move the object, and you are going to see the behavior of the image. You can even change the color of the image. We can make it color green. So the image is there. We can move the image. Let's move the triangle actually further, and then we see the behavior of the image. The image also moves further, and then the distance between the triangle and the mirror line is also the same as the distance from the mirror line to the triangle. So when I move the triangle to the right, the image moves further to the left. When I move the triangle up, the image also moves upward. When I move the triangle downward, the image also moves downward. And then you can see the mirror line remains there. So I can even move the triangle to the other side, and then the image moves across to the other side also. So here we can confirm that the matrix T is equals to -1, 0, 0, 1 is a matrix of reflection on y-axis. I can also move the jellyfish to the other side, and that property still holds. The image will move also to the other side, and the distance is also maintained, and the angle is also maintained, an angle of 90 degrees.
Next, we have the matrix 1, 0, 0, -1. We are going to pre-multiply this with the object 2, 1, 4, 1, 2, 4. We'll get the image as 2, -1, 4, -1, and 2, -4. And you can also see that on the figure below.
The matrix T is equals to 1, 0, 0, -1 is a matrix of reflection on the line y is equals to 0, and this line is the x-axis. I have applied this matrix to the jellyfish, and I can move this jellyfish for you to see the behavior of the image. The image is the faded line, it's the faded one. So when I move the object further upward, the image moves further downward. When I move the object downward, that is closer to the mirror line, the image also moves closer. Then we can explore the properties of reflection. The distance from A to the mirror line is also the same distance as the distance from the mirror line to the image, and that is A prime. Actually, when the distance is 2 units, also on the other side of the image, the distance is also 2 units. And then the angle that is formed by the line A prime, and the mirror line is an angle of 90 degrees. That is, the line A prime is a perpendicular bisector of the mirror line. I can move the object to the other side, and then the image also moves to the same side. I can even move the object across, and then the image will also move across to the other side. I can apply this matrix on a triangle. So let's draw a triangle. Our triangle is GHI. And then we can apply the matrix. Our matrix is T, and then our object is T1. And this gives us an image, and that image is G prime, H prime, I prime. We can change the color of the image. We can make it color blue. Then we can move the object to see how the image behaves. When we move the object to the right, the image also moves with the object to the right. We can move the object closer to the mirror line. The image also moves to the mirror line. We can even move the object to the other side, and the image will also move to the other side, and the distance is also maintained. That is the distance between the object to the mirror line, and that distance is the same as the distance from the mirror line to the image. And this is proof that the matrix T is equals to 1, 0, 0, -1 is a matrix of reflection on the x-axis, or the line y is equals to 0.
Next, we have the matrix 0, 1, 1, 0. When we pre-multiply that with the object 2, 1, 4, 1, 2, 4, we get the image as 1, 2, 1, 4, and 4, 2. And we can see that on the figure below.
The matrix 0, 1, 1, 0
you can
is a
also
matrix
watch
of
this
reflection
video
on the line x is equals to y. I have applied that matrix on the jellyfish, and I can move the jellyfish, and you are going to see the behavior of the image. The image is the faded one. When I move the object further from the mirror line, the image also moves further away from the mirror line. And then when I move the object closer, the image also moves closer. And then we can explore the properties of reflection. When we join A, that is the object, to A prime, the image, and then we measure the angle between that line and the mirror line, the angle is 90. And that is evidence that that property, that the object, when we join the object to the image, we form a perpendicular bisector. And then the distance from A to the mirror line is also the same distance as the distance from the mirror line to A prime. We can even move the object to the right, and then the image also moves with the object. When we move the object to the left, the image also moves with the object. We can even move the object across. The image also moves across. And this is evidence that this is reflection on the line x is equals to y. I can apply this matrix to a triangle. So I can draw a triangle. So my triangle is J, K, L. And then I'm going to apply this matrix. So I'll say apply, then matrix, my matrix is T, and then my triangle is T1. So we have the image, and the image is J prime, K prime, and then L prime. We can even change the color of the image. The color of the image is green. And then we can move the object to see how the image behaves. So when you move the object closer to the mirror line, the image also moves to the mirror line. We can move the object across, and then the image also moves across. We can move the object maybe to the right. The image also moves with the object. We can move the object downwards. The image also moves with the object. And so this is evidence that the line, the matrix 0, 1, 1, 0 is a matrix of reflection on the line X is equals to Y.
We also have the matrix 0, negative 1, negative 1, 0. When you multiply this within our object 2, 1, 4, 1, 2, 4, we get the image as negative 1, negative 2, negative 1, negative 4, negative 4, negative 2. And we can also see this on the figure below. You can also watch
the matrix 0, negative 1, negative 1, 0 is a matrix of reflection on the line Y is equals to negative X. I have applied that matrix on the jellyfish, and then I can move this jellyfish. I can move it closer to the mirror line. The image also moves closer to the mirror line. When I move the object further from the mirror line, the image also behaves in the same way. And then we can check the distance. The distance from A to the mirror line is the same as the distance from the mirror line to the image, that is A prime. Then the angle formed between the line A prime and the mirror line is an angle of 90 degrees. And that is to say that A prime is the perpendicular bisector of the mirror line. And then we can apply this matrix. Actually, I can first of all move this object across. And then the image will also move across. Then we can apply this matrix on a triangle. So I'm going to draw a triangle. And this triangle is a triangle L, M, N. And then I'm going to apply this matrix on this triangle. My matrix is T, and then my triangle is T1. And then I will get the image. The image is L, L prime, M prime, N prime. We can change the color of the image to color purple. and then we can move the object. When we move the object further, the image also moves further from the mirror line. When we move the object closer to the mirror line, the image also moves closer to the mirror line. And then we can even move the object across. The image also moves across. And we can check the distance. The distance is maintained. That is from the mirror line to the object. That distance is the same distance as from the image to the mirror line. And this is evidence that the matrix 0, -1, then -1, 0 is a matrix of reflection on the line y is equals to -x.
Thank you for watching this video. In the next video, we will discuss rotation matrix. Also, this book is available in all reading bookshops. It is called Mathematics Formula Revision Book, your best revision companion, suitable for secondary education. If you need a copy, you can also call 0721 983 057. Please subscribe to our videos, also like and share widely.